Okay, so we're looking at this final exam review. We've already talked about things on test 4. I might not get to test 3 today. I want to do test 1 and test 2 today if I can. So I posted the tests for test 1, 2, 3, and 4, and the solutions for 2, 3, and 4, right? All on Blackboard. I don't have solutions for test 1 because I tried it with MathXL to kind of be, everyone got a different test, but I'm going to really hone in on the things I want you to do that are on test 1. So test 1, I really like numbers 1 and 3. Let me show them here, but you should have it open at home. So test 1, I really like something number 1 and number 3, because you had trouble with those from chapter 12. And then difference quotient, for sure, but we've done that on many tests. And I'm thinking maybe a piecewise function, probably not, but we use them a lot in calc. And then complete the square for sure. So I definitely like 1, 3, 9, 10, and the difference quotient problems. And there's 3 possible difference quotient problems for us to do. Actually, there's a trig one too, but I'm not going to put that on the final, right? That was a little bit more advanced. So on test 1, I like problems 1, 3, any kind of difference quotient, 9 and 10. On test 2, because question 1 and 2 are difference quotients again, I really like 3, 4, and 5. On test 3, 2, 6, 8. I think that's what 2, 6, 8. So 2, 6, 8, 10. And I'm going to go through these today. I did all of this with the morning class. And then test 4, I like 1 through 8. I'm not going to ask you a simple trig application where you have to use the tangent or a law of sines, because it's all too easy, and most of you got both of those right. So that's what I'm looking at, and I'm going to try and pick 12 to 15 problems. So 12 to 15 problems in 2 hours. I should be able to do that in my head, but I can't. 120 divided by 15. 8 minutes a problem. At max, right? I took my 2 hours divided by 15 questions. So that's what I'm thinking about, right? And again, our test is when Monday 12:15. Monday 12:15. I will be here at 12 in case you forget and you're early. They have this weird schedule because if we were face to face, you have to let the other class get out, right? That kind of thing, and get set up. But it doesn't make sense in remote. But they didn't want to change anything, so it's weird. Just make sure you check your final exam schedule for your other classes. And so since we're taking our exam on Monday, we don't meet Wednesday or Friday. You have those times to study for your other exams, right? So it's not like a regular schedule. We meet only on that next week for our exam. All right,
Professor.
Yes, Joel, what's up?
I thought since class ended the 19th, so we just don't have class after the final exam.
Exactly. Thank God. Right? Believe me, you'll still have other exams, and then you'll have the crash, right? The crash when you're finally done, you're like, oh, you don't want to go to a class after that. All right, here we go. Let's look at, where's my PDF? So here's test 1, and let's look right away at this first question. Find the sum of the sequence, right? So this one's pretty easy. I will make yours a little bit more difficult. If you want me to do another one, maybe a little bit more difficult than this one, I will. Not all of you got this question, but all of you will get the same question on the final. So the sum of k equals 1 to 6.
Professor, you're not sharing your screen.
Oh boy, I did all of that talking and writing without sharing anything. Thank you, Saria. Well, it isn't on the recording, so. But anyway, let me just show everything I just said. I have it all written down. Right, so there's the test 1 questions. Right, 12 to 15 problems, 8 minutes per problem, and these are the questions I really like. Okay. I think test 3, there might be more that I want you to do, so we'll come back to that list in a second. Okay, so anyway, here's our first problem. This is test 1, number 1. I want you to find the sum of k equals 1 to 6 of 7k plus 3. Right? And so the whole idea here is, and on your formula sheet, you have all of these summation formulas, right? That the sum of the sum of 1 is n. The sum of I is n times m plus 1 over 2. The sum of I squared is n times m plus 1 times 2m plus 1 all over 6. And I really don't see me going to the cubic one. I see, so maybe a quadratic, right? I'll put a full quadratic on your test. So how do we do this one? Well, certainly we could write out each term and add them up, and that's not a bad thing for you to do to make sure you're getting the same answer, right? So, so I could write out each term, right? 7 times 1 plus 3 plus 7 times 2 plus 3 plus 7 times 3 plus 3. This is not what I want to see, but this is a nice way for you to make sure you're getting the right answer. We want to do something a little bit more sophisticated. Sorry, 7 plus 6 plus 3. Right? So what do I get? I get a 7 plus 3. I get a 14 plus 3, 21 plus 3. And I think I get 165. I forget. But I can do this, right? 10 plus 17 plus 24 plus 31 plus 38 plus 45. Oops, those are pluses. Come on, Robert, wake up. And then I can just, and so I'm doing this for myself to know I got the right thing, right? $165. But is that what I want you to show? No, I want you to show the more sophisticated way, right? Using these sums. So the sum of k equal 1 to 6 of 7k plus 3 is the sum of 7k plus the sum of 3, right? I tend to get a little lazy with my notation, but I know it's going from 1 to 6 in each one. And so what do I get? 7 times the sum of index k plus 3 times the sum of 1, right? And so I know the sum of 1 is n, and I know the sum of k is n times m plus 1 over 2. So I get 7 times n plus 1 all over 2 plus 3 times n, right, for n equals 6, right, that final indice. So what do I get there? I get 7 times 6 times 7 all over 2 plus 3 times 6, right? For each n, yep, I put in the 6, right? So what, I get 21 times 7 plus 3 times 6. You can see the 3 times 6 when I did it up here, right? You see the... And that's 165 again, 21 times 7. So, what do you think?
The sophisticated method is faster.
One more time, Ryan. Sorry.
The sophisticated method is faster.
Oh yeah, it's better. And we use it in Calc 1 and Calc 2. So that's why I've taught it to you, so that when you see it in Calc 1, you won't be in complete shock.
Professor, so in this
Yes.
case, the reason why we use the second rule on the first sum of 7k is because technically that I is k.
Exactly. I can use any letter I want
Any letter,
for the
right.
for the index. Yeah.
Okay.
I tend to use I because I'm trying to stress index the first term, the second term, the third term. But you'll see K and J and all kinds of letters being used. N.
Right.
Yeah. So I can see more of a question like for you, find the sum from. So very similar process. The sum from I equals, what if I started at 3 to 11 of like 2i squared minus 5i plus 3, right? I can see something more like that would be interesting to me. So I do the sum to 11, I do the sum to 3, and then I subtract the 2, right? I'm sorry, I do the sum to 11, I do the sum to 2, right? And subtract the 2. So something like that for sure, because you'll see it in Calc 1. I put it on our first test, right? A lot of you had trouble with it, so I'm putting it on the final.
Can we do this problem?
Sure. Let me set it up and not actually do the whole thing, right?
Okay.
So I know the sum from I equal 1 to 11 of 2i squared minus 5i plus 3 is the same thing. It's 2 times the sum of I squared minus 5 times the sum of I plus the sum of 3, right, for n equals 11. So the sum of I comes from n times n plus 1 times 2n plus 1 all over 6 minus 5 times n plus 1 all over 2 plus 3n, right, for n equals 11. And so now all I have to do is plug in 11 and I get that sum. But I have to, notice my sum says start at 3. So I really have to, subtract off the sum of the first two terms. I could do that a couple of ways. I like saying the sum from I equal 1 to 2 is the same, right? So it's 2 times n plus 1 times 2n plus 1 all over 6 minus 5 times n plus 1 all over 2 plus 3n for n equal 2. And then once I get those two results, I subtract them and I got the whole sum. And that's something you could just put into the web and say, what's the result? Make sure you get it correct. You can see all of those in chapter 12 as well in the textbook. The next one I like is number 3 because I gave one like that and a lot of students had trouble with it. So I'm using an arithmetic sequence. I know a 15th term, I know a 60th term. I'm trying to come up with the first term, I'm trying to come up with the common difference, and I'm trying to come up with the nth term, right? So let's do this one. So test 1, number 3. So first of all, I know a sub n is a sub 1 plus d times n minus 1. This is my formula. This is on my formula sheet. Right? This is the nth term of an arithmetic sequence. And a sub 1 is the first term. D is the common difference. Also what? What else is D? It's the slope. Remember, arithmetic sequences are all linear, right? So everyone turns into y equals mx plus b. So you can see almost a y equals dn plus b here, right? So d is the slope. So on our problem, we have the 15th term is 0, the 60th term is negative 90. So we're going to create two versions of this nth term and try and figure out the two unknown variables. Right? You remember doing this semester?
Yep.
So a sub 15 gives me a sub 1 plus d times 15 minus 1, because remember, n, that subscript is my index, equals 0. And a sub 60 is a sub 1 plus d times 60 minus 1 equals negative 90. So from those two pieces, I'm gonna be able to solve for two variables, right? Because I've got two variables and two unknowns and two equations. So I can simplify them a little bit now. A sub 1 plus 14d equals 0, and a sub 1 plus 59d equals negative 90. How are we doing?
Good. That was just this. I forgot what it was called. Elimination.
Yeah, exactly. Oh yeah, right. Just taking it. I lost somebody. I don't know who left. Oh, Abraham. Okay. So this one I'm just going to subtract the two, right? So a1 minus a1 is 0. 14 minus 59 is negative 45d. And 0 minus the negative 90 is 90. So d is 2. Oh, sorry, negative 2, right? So I'm going to be subtracting negative 2 every time I move to the next term. Slope is negative 2. Once I know d, I can plug it into either equation. So a sub 1 minus 2 times 14 should equal 0, right? I'm plugging it into a sub 1, but I know d now. So I get a sub 1 minus 28 is 0, so a sub 1 is 28. Once I know the first term and the common difference, I get the general term. So a sub n is 28 minus 2 times n minus 1. It's possible I don't put that one on the test because it's not in Calc 1, but definitely the first one is on the test. On the test, it asks for a recursive definition there too. I don't do that one at all. I won't use the recursive. Give a recursive formula for the sequence. So the next one is difference quotient. Number 5 is a difference quotient problem. And there are 3 difference quotient problems I'd like you to be able to do. What are they? What are the 3 difference quotient problems I'd like you to be able to do?
The one f of x with x plus h.
Yeah, exactly. But what kind of functions am I going to ask you to do? So like a polynomial, so like 5x minus 3x squared, a radical, square roots, right? Wow, thank you. So like 1 minus 3x, and a rational, like x over 2 minus x. So you should be able to do a difference quotient on any type of function like that. And of course, you should be able to graph it and then find a secant line, right? Find the slope using the difference quotient and find a secant line. Now, all that kind of good stuff. Which one do you want me to do here?
Keep it irrational.
Yeah. So h of x equals x over 2 minus x. This one's kind of nice to do because we get to do all of those other things as well. We know there's a vertical asymptote at 2, right? We know there's a horizontal asymptote at -1, right? We know we have the point 0, 0 on there, and that's kind of giving us a hint at the mother function, but it should be pretty clear that h of 2 is 2 over 2 minus x, so that's really behaving like -1 over x, right? And that's pretty easy to see when you think about that one point that we have there. And let's just pretend that we want the secant line from -1 to 1. Right? So we're going to use the difference quotient to get the slope, excuse me, of the secant line. And then, right, get the equation from one of the points and the slope. All right, so let's do our difference quotient. So our dq here is going to be x plus h over 2 minus x plus quantity x plus h minus x over 2 minus x. That's the original function, all divided by h. Just my preference. Everybody okay, though, before I move on? So my preference here is to get rid of those interior parentheses. I don't know why. Sorry, that's a 2. And then it's pretty clear I'm going to use my LCD there of the wrapped denominators, right? So I'm going to multiply top and bottom by 2 minus x minus h times 2 minus x all over 2 minus x minus h all over times 2 minus x. We do this a lot in Calc 1. We do this process a lot, which is why I've been stressing it so much. I want to multiply to numerators right? Everyone okay? So I've got my original function in black, and when I'm distributing in red. And again, like I don't care if you're skipping a couple steps, but if it looks like you're doing it right, I'm done. You're good. If it looks like you don't even know the formula for the difference quotient, then I'm not going to look at it. I'm just going to give you a 0 on it. Right? Either you can do it or you can't do it. If you can't do it, you're in trouble in calc. Okay? So a bunch of things cancel here. And I'm trying to rewrite without being Russian. So now it's just horrible algebra. And that's what happens a lot in Calc 1 too. It's just like the concept is easy, but the algebra is hideous. So if you've got algebra issues, you're going to need to review your algebra over the winter break. Whether you're repeating this course or you're taking Calc 1. I'm saying Khan Academy Algebra 1. It's like 8th grade. Khan Academy Algebra 2. Right? Khan Academy Trig. Khan Academy Pre-Cal. Right? Trying to do a couple hours every day, you might get up to the trig. Right? Maybe you only have to review the trig. Maybe you do just Khan Academy Trig class. It's free. It steps you through the whole course. It gives you lots of practice problems. Right? So you don't have to copy me here. You're just racing me, really. I'm just doing all that distributing. And I see a bunch of things cancel. Everything without an H better cancel, right? In fact, even some things with a factor of H cancel. And then finally my H's cancel that single factor of H. So the difference quotient turns out to be 2 over 2, quantity 2 minus x minus h times quantity 2 minus x. There's my difference quotient. That difference quotient is going to get me the slope of that secant line, right? But I have to figure out what x is and what h is. So you can see I've picked my first x at -1 and my last x at 1. So I can figure out that distance there, that's h, right? So h is 2. So I'm going to let x be -1 and h be 2. Everybody with me? I'm just doing the arithmetic in my head real quick. So 2/3. Did I do something wrong? Oh, H is 2. Sorry. Yeah, I did something wrong, right? Oh, no, I got it. Go ahead. Come on.
How do we find H again? Do we just count from the graph?
It's always, yeah, it's always the distance between the x's. So
Okay.
my first x is -1, my second x is +1, the distance between is 2. Right, I got to take 2 steps on the x-axis. That's my h.
Right. And for the secant line, will you ask us to, like, will you give us, like, find it from -1 to 1, or is it always
Yeah.
-1 to 1?
Yeah. Well, I will always give you that piece, but when you're practicing,
Okay.
you're going to have to decide on what it is, right? So pick some function, pick points on the function, see if you can come up with the whole thing.
Got it.
Yeah. So I just have to find a point. So I know that f of -1 is what? -1 over 2 minus a -1. Right? X over 2 minus x. So I get a -1 over 3. That's fine. So I can use that point, right? Let's just see what the other point is real quick. 1 over, oh, that was easier. So I get 1 over 1. So let me use that point for my secant line. I get y minus 1 equals 2/3 times x minus 1. Right, I'm using that y minus y sub 1 equals m times quantity x minus x sub 1. Right? So I get y equals 2/3 x minus 2/3 plus 3/3 is plus 1/3. Kind of looks possible. Definitely a positive slope, definitely a positive b value. So I'm thinking it's pretty spot on. How do I know for sure that I got it right?
So you can just plug in your x's.
Graph it, yeah, graph it. Should be pretty easy to see that you've got it right just by graphing. Nice. So make sure you practice all 3 of those secant slopes, right, with the difference quotient, because at least one for sure will be on there. I think I put you've had all 3 on your tests. Through test 1, 2, or 3, I've had all 3 of them on there, right? So you should be able to do it by now, because you will have to do it in Calc 1. Nice. Let's do number 10.
Professor?
Yes, Daria.
Could you go back to the secant line part? I didn't really
Sure,
get that.
no problem. So you're okay with the difference quotient, right?
Yeah.
Good. And then I found out what my x and h were from the graph, and then I found the slope of the secant line. Yes, you with me there?
Yeah.
And then I just need 1 point. So I found f of -1 is -1/3. I found f of 1 is 1. I used the easier, the one that didn't make me work as much, right? And then I'm using this equation from, if you took Math 50, you were there. If you took Algebra 2, you used this. In fact, in Algebra 1, you used it. Well, Algebra 1, and they usually use the mx plus b, right? But this is baby. This is middle school. We want to use this one all through Calc 1, right? So then we found the equation of the secant line. Daria, are you okay there, or am I?
Yeah, I got it.
You got it? Okay. In my review of our class, my boss said, you use different languages in the book. Do you think that's a good thing? And of course, I didn't want to say, well, she said, mother functions. Who says that? I didn't want to say. I like saying that because it sounds like I'm cursing, but the book will use parent functions, right? I'm like, is that really far off, that a mother function and a parent function? So let's look at number 10 here on this one. Where is it? There it is. Yeah, so we're going to complete the square to find the shift of this particular function, where the vertex is and how to graph it and all of that, right? Sorry, it's negative 3x squared minus 36x minus 104. So we'd like to see how this thing is a shift left, up, and a vertical stretch down of the mother function x squared, right? So g of x is just plain old x squared, right? And I think we're going to see f of x is negative 3 times x plus 6, all quantity squared plus 4. I think that's the answer, just because I did it this morning. But let's do the process. So the process is to factor out that leading coefficient from x squared and 36x, but leave the 104, leave the constant. So I get an x squared plus 12. Is that right? Yes. Here I'm distributing back in my head to make sure I did it correctly. And so I want to find the k value. K is 12. It's that coefficient of x inside of the parenthesis. So half of k is 6, and half of k quantity squared is 36. So I'm going to complete the square by adding that 36 inside and then adding 108 on the outside. What? Where did 108 come from? Where did 108 come from?
36 times.
Exactly. Negative 3 times the 36 is negative 108. I want to make sure I cancel that, right? I can't just add negative 108 to something and keep equality. So I have to add that negative 108 and cancel the 108. So this is what I've done on purpose. I've completed the square. This particular piece in here is a perfect square. I could factor it. I don't have to. It's always x plus half of k. It's always x plus 6 half quantity squared. And there it is. I can see my vertex. Right, the vertex is negative 6, 4. So I know I moved left and up. And then my stretch, my vertical stretch, is negative 3. So I'm gonna take the whole thing, turn it upside down, and stretch it 3 down. Right? You remember doing this? It's fun. Do we complete the square in Calc 1? What do you think?
Sure.
We do. We complete the square in Calc 1 and Calc 2. It just never. What's the beautiful thing is we've been torturing you with this algebra stuff for I don't know how many years now, right? But you finally get to see what it's needed for. When you take Calc 1, you finally get to see where it all connects. So, you'll still be angry, but at least you'll be in the know finally. Like, what the hell are they doing this to us for? I want to kind of get a picture of everything, including the mother, the daughter, the granddaughter, and the great-granddaughter, right? So for the mother, we just have x squared, right? And we're trying to focus in on that 1 by 1 box, right? That 1 by 1 box is the key, and I missed it pretty badly, didn't I? I need to hit the origin in that corner of the box. So there's y equals x squared. That's the mother function. I'm going to just take care of the moving first, vertex first. So I got to move that 1 by 1 box over 6 to the left. So 1, 2, 3, 4, 5, 6. So that box now is here, and there's the new function. Y equals x plus 6 quantity squared. So I took that box and moved it left. Now I'm going to take that box that's moved left, 1, 2, 3, 4, 5, 6, and move it up 4, 1, 2, 3, 4. So my box is now here, right? And y equals x plus 6 quantity squared plus 4. And now I'm going to take that box that I moved 6 to the left and 4 up, and I'm going to stretch it down 3. So there's my final granddaughter. And yes, I would like you to show me all that on the test. How we doing? We feeling okay? We feeling good about this? No new stuff on the exam, right? Just I'm going to change the function and ask you to show me that you can do it all.
So, Professor, so the first one is the mother function on the first graph. Is that where you always start at?
Yes, exactly.
Okay.
Yeah, the mother, and then I did the horizontal shift, and I did the vertical shift, and then I did the vertical stretch.
Got you.
Professor?
Yes. Well,
So on the test, you want to see all 4 of them going step by step, or
I guess
you don't want
you
just
could
the
show
one?
me. You could just show me the last one, but I think it's easier to think about them as just, all right, where's it moving left or right? Where's it moving up or down? And then
Right.
how am I stretching it out? But that's,
Okay.
you know, if you gave me something that, if you gave me this and this, right? I believe me, I'm not going in there and looking for, oh my God, did they use the right font on their X's? I'm not, right? We're all burnt out, right? We're all done. I'm just saying, do you know what you're doing, or do you not know what you're doing? If you know what you're doing, perfect. 10 out of 10, right?
Okay.
Nice, that's it. I like that stuff for test 1, right? Let's take a look at test 2. I can't ask you everything, right? It's just impossible for me to ask you everything. We don't have enough time, right? We can't, we're at our this is what I was thinking about this morning. It's like, thank God this semester's almost over, and then in like 3 or 4 weeks we start again. Oh my God. So we already did, this is test 2 now I'm looking at. We already did something like 1, exactly, right? We didn't do a difference quotient for quadratic, but those are easy, and you got the solutions. We did we do this one, number 3, the other day? Did we do it Monday? I think we did, right? So I like 3, 4, 5 here. Did we do 3 Monday? Anybody remember? Let me look at our notes from Monday. Did we do that?
No.
We didn't.
I don't think we did.
Okay.
Yeah, I don't think so.
So I'll do 3, 4, and 5. Sound good? And then we'll
Yeah.
quit for today. And then you'll work on test 3 and test 4 for anything you want me to do Friday. Okay. Nice. So it says it gives me a function, a polynomial. It wants me to list out the possible rational roots and then it wants me to synthetic divide with 4/3, long divide with x minus 1/2, and then factor this thing as complete as I can, only with real zeros, right? So if I get complex zeros, don't bother with it. It's definitely a question like this on your test. So I've got f of x equals 6x to the 4th minus 23x cubed plus 32x squared minus 19x plus 4. Possible rational roots, not a problem, right? Factors of the leading term right? Factors of the constant plus the leading term over the leading term. So plus or minus 1, 2, 4. There's the integer factors of the constant, and then over 1, 2, 3, 6. Right? So the first one is asking you, is 4/3 in there? Yes. Right? So x equals 4/3 is a possible rational root. How can we find out if it is a root? Well, we certainly could look at the graph, or we can synthetic divide with it. So that's what we're going to do. We're going to take 4/3 and synthetic divide into 6, negative 23, 32, negative 19, and 4. How's everybody feeling here? Wilder, what's that? Square roots what?
Oh no, this was like way earlier.
Oh,
We were asking about difference
you're right.
quotients.
You're right about the difference quotient. I'm sorry.
Yeah.
Yeah. Theory about the possible rational roots.
Yeah.
Yeah. So it's just so it's something I don't know if you remember, but I created a bunch of polynomials, right? And I looked at the leading terms, leading coefficients, and the constants, and then when I FOILed them all out, you could see, and then found the roots. You could see they're coming from those coefficients, those leading coefficients, and those constants, right? And so that's, the theory is if you do have a rational root, it's got to come from factors of this divided by factors of this, right? So integer factors. So 1, 2, 4, all over 1, 2, 3, 6. Integer factors of 4 over integer factors of 6. Right, so if you even just thought of like 7x minus 1 times x minus 3, right? And you could see that what's the first root? 7. What's the second root? 3, right? And then if I distributed it out, I get what? 7x squared minus 4x plus 3. So you can see I'd have factors of 3, 1 or 3.
First root is 1 over 7.
1 over 7, yes, exactly. Thank you. 1, 7. So you can see the factor of 3 or the factor of 1 over 7. Thank you. So we bring down that leading coefficient every time, and now multiply by 4/3. What is that?
8.
8, yep. And then add. So negative 15 multiplied by 4/3, negative 20, add negative 12, multiplied by 4/3, negative 16. Is that right? No, what did I do wrong?
It's positive 16.
Yes, because positive 12, thank you. Negative
Positive
3,
12.
yep, and then a negative 4 and a 0, got it. So I got a 0 remainder, so I have a root, right? Excuse me. X equals 4/3 is a root. So x minus 4/3 is a factor. And now f of x is that factor times the depressed equation, right? The depressed equation is coming from here, right? 6x cubed minus 15x squared plus 12x minus 3. You remember all the fun we had with this? So the next part of my question is, can you show using long division that x minus a half is a factor? So we're going to do x minus 1/2 long divide into that depressed equation. So I'm asking x times what gives me 6x cubed, and that's 6x squared, right? And then I'm going to come back and multiply, and I get 6x cubed minus 3x squared. Everybody with me? Nice, change the signs and add. That first one goes away, right? We eliminate all of this in synthetic, this process. So, but I get negative 12x squared plus 12x minus 3. And then rinse and repeat, right? So x times what will get me to negative 12x, and that is what negative, get me to negative 12x squared. That's negative 12x. Come back and multiply. Change the signs and add. X times what will get me to 6x? X times 6, right? Change the signs and add. So that gives me that quotient that I just got is my new depressed equation. So f of x is now x minus 4/3, x minus 1/2 times the depressed equation of 6x squared minus 12x plus 6. That one you could factor out another 6. And then the remaining quadratic has complex roots, so nothing else to do. Is that right? Or is that factor more? No, it factors more, doesn't it? No. Yes. It does. I thought it.
Yeah, negative 1 and 1.
Yes. Yes, exactly. So we have a multiplicity. Remember that? You're like, don't do it to me, please. Once you get down to a quadratic, you should be able to factor without doing any more synthetic or whatever, right? Oh, number 5 doesn't really have to be there because if I do it at all, I'll do it with the log function, right, which is on test 3. So let me do this last problem today, and then we'll work on test 3 on Friday. Test 3, test 4, or anything you want me to do, okay? So test 2, number 4. And they've got the function f of x equals x cubed minus 1 over x cubed minus 3x squared minus x plus 3. And that's my standard form. And then I want to start factoring. So this one really factors pretty easily. Of course, if you had trouble factoring it, you could use synthetic, right? I'm just doing it all in my head. You factor it any way you can, right? Because we taught you factoring in Math 50 if you took it here, or you learned all your factoring in Algebra 1 and Algebra 2 in high school. So that's my factored form. And then I can see some two factors will cancel, right? So I get my simplified form, but it's important that I remember that I must keep the domain of the original. And so that's our first question. What's the domain? Right, so it's easiest to find the domain in the factored form, right? And I like that one as an interval better. So minus infinity to -1, union -1 to 1, union 1 to 3, union 3 to infinity. I've got to leave out all of those values. The -1 has to be removed, the 1 has to be removed, the 3 has to be removed. It's like I'm drawing a number line. Yeah.
So on the final, do you want us to write the domain like that, or can we leave it as x can I equal 3?
If I want an interval, I'll ask you for 1.
Okay.
It's kind of cool if you could show off and do the interval. So you can see the 3, right? The 3 cuts in my number line. And I'm trying to glue them back together with that union symbol. So what else do we have to find? I'm forgetting the problem. Let me read it again. Yeah, the more you show off on the final, the easier it is for me to bump your grade, right? So you do decent in the final, you end up with a B in the class, right? You ace the final and you end up with a B in the class, I can really consider giving you the A, right? If you give me a perfect exam, I can give you whatever I want. I've not had many students complain about a higher grade. I'll never bump down a grade, right? But if you got an A and you say to me, I don't think I deserve the A, give me the B, I would do it. But I'd also ask if you had a psychiatrist. So intercepts, asymptotes, and a hole, if any, short run behavior, and label the graph. Almost done today, thank God. So intercepts. I think I got an x-intercept, right? No, I don't, because my numerator is never 0, except at 1, but that's a special case. So I only have a 0 and -1/3. Right, I only have a y-intercept. Asymptotes. We've got a horizontal asymptote of y = 1. Vertical asymptotes at all of those, 2 of those domain pieces, right? At x = 3 and x = -1. Everybody with me there? This is so easy now, isn't it? Isn't this easy? How did I get the horizontal asymptote? Mother function over mother function, right? X cubed over x cubed is 1. How did I get the verticals when the denominator equals 0 and the numerator does not? What about the whole? So f of 1 is 0 over 0. That's hinting that there's a hole there, right? So f of 1, plugging into my simplified version, is 1 squared plus 1 plus 1 all over, what was it? I forget already. Oh yeah, 1 minus 3 times 1 plus 1. So I'm plugging that 1 into the simplified version to see what I got for where the hole exists. So it's negative 3/4. I think I'm ready to draw. XY axis. Vertical asymptote at y equal 1. Sorry, horizontal asymptote at y equal 1. Vertical at negative 1 and 3. I have the point 0, negative 1/3, right? And at 1, I have a hole at 3/4. Now, I'm using my calculator, right? So I already know that this thing looks like this, okay? But I can verify, at least using some short run behavior, right? F of 3 is what? 3 squared plus 3 plus 1 over x minus 3 times 3 plus 1. I'm plugging the 3 in this time into the simplified version. And I get 9. I get 13/4 times 1 over x minus 3. And so you can see the mother function of 1 over x. Right? So 1 over x looks like this. And we get that right away from these two pieces. But of course, you have your calculator, right? You'll have your calculator and you'll be able to know you have this one right long before you finish it. So we'll do items on test 3 and test 4 on Friday. Try and look at them ahead of time. I'm going to try and up my